Okay, so let's have a review of reactions, chemical reactions. And so you've probably seen this before in your chemistry class, but it's a good review. So the first thing we want to talk about are reaction equations. So let me just write this out here. A reaction equation, and this is a reaction equation from the book. But here's a reaction equation. First thing you should notice about this reaction equation, it is not balanced. So if we were to try to analyze a reaction going on between SO2 and oxygen using this equation, we'd get it wrong. Not balanced. On the other hand, this is an equation that is balanced. And you should know that it's balanced because the number of sulfur atoms is the same on each side, and the number of oxygen atoms is also the same on each side. So we have 3 oxygens on the left, 3 oxygens on the right, 1 sulfur, and that's a balanced equation. And there are many, many more balanced equations we could write out. And I could just, write these continually. Just write these all day long. The point being that if we have an equation for a reaction, we need to have that equation balanced. So one of the first things you should do when you're studying a reaction is make sure you have a balanced equation. Something like this or this. So the number of atoms on the left-hand side equals the correspondingly equivalent number of atoms on the right-hand side. And let me just say one little thing here. It doesn't matter so much how we write this out. So for instance, I could also write this out as 2SO2 plus O2 goes to 2SO3. Just basically doubled the numbers in front here. Double this, this, and this. It doesn't matter because this, in the end, this will give us the same end results. Now these numbers here, the 2, and this would be equal to a 1, and then this 2 here. These are the stoichiometric coefficients. That's what they're called, stoichiometric coefficients. And these come into play for analysis of a reaction. We just need to remember that for a balanced equation, the stoichiometric coefficients are the numbers in front of each reaction. And let me write this again, remind you, 1 would be here, 2 here, 1 here, 1, 1/2, 1. So let's analyze this a little further. Let me write this out. 2SO2 plus O2 goes to 2SO3. So we have this reaction here. Just put it up there. The ratio of the various species in this reaction is a stoichiometric ratio. Stoichiometric ratio. And so let me just give you an example. In this particular reaction, we have 2 moles of SO3 generated per 1 mole O2 consumed. And this is just taken from the stoichiometric coefficients. If I just look at here, 2 moles of SO3 are generated every time this reaction takes place. 2 moles of SO3 are generated per 1 mole of O2 consumed. And we could write out other ratios here. 2 moles SO3 generated per 2 moles SO2 generated, which is the same thing as 1 mole SO3 generated per 1 mole SO2 consumed. And so this is, again, this is the stoichiometric ratio. And let me just explain to you how this can be useful. So let's just assume, for instance, that I have 1,000 moles of O2, and they react according to this reaction up here. and I want to know how much of SO3 is generated. So let's just assume all 1,000 moles of O2 react, so I can use this stoichiometric ratio right here to calculate that. So 1,000 moles of O2, so that's how much I start out with, and then I use the ratio here, 1 mole O2 consumed divided by 2 moles SO3 generated. And if you just look at this, the moles of O2 are canceled out, so that leaves me with 2,000 moles SO3 generated. So very, very straightforward on there when we're trying to calculate how much of a particular product is produced. We can just use the stoichiometric coefficients based on how much reactants we have and how much of those reactants react on that equation to determine how much of the products we get. Let me just say one thing here, that I'm putting here, moles and moles. We could also use pound moles. For instance, I could write 2 pound moles of SO3 generated per 1 pound mole of O2 consumed. It could be other units, kilomoles. So for instance, 2 kilomoles of SO3 generated over 1 kilomole of O2 consumed. It doesn't matter as long as we're consistent. We cannot use mass, so for instance, I couldn't just substitute in here 2 kilograms over 1 kilogram. This is always in amount of material or in moles, whether that's pound moles or gram moles. So there we have it there, just a review on stoichiometric coefficients and stoichiometric ratios.